Hello, greetings, and welcome, everyone. Preemptively, a little bit of a Happy New Year wish to all of you. I hope it's a good one. This is the last day of 2018 for those of us that are not, far enough east to have already gotten into 2019. But this will be our last stream of 2018, and I hope it is a good one. For those of you in Europe, it is not many hours, just a handful for those of you in Western Europe, and fewer if you're further east. But hopefully you are doing something fun for the end of the year, and hey, maybe this is the fun thing that you're going to do for the end of this year. So, welcome everyone. We are going to go ahead and get started. I mentioned in a tweet, and I also mentioned to some other people that are in our Discord. If you're not in our Discord, you should be, first off. Link over there in the chat. And I mentioned to people there that I had been working on a kata that I thought would be an interesting one. I haven't seen anyone do this one before, and I was like, hey, this sounds like a fun thing to do, and I think you could do it in a pretty short amount of time in a handful of ways, varying from simplistic approaches, where you're basically brute forcing, all the way to actually taking a logical approach to it. So what I think is interesting about it is you can create as simple or complex a test harness as you like, and obviously for a kata you could start with a very simple test harness. And what I like about that then is it's a kata that can have a couple of tests to begin with that translate to many languages easily. So the kata that I was thinking about doing, and I'm going to give you guys the explanation, so welcome, glad you're here early. We are going to solve Sudoku puzzles using C#. Should be easy. My initial thought is let's just write a thing that brute forces it. And then once we've done a brute force algorithm, we can potentially try to find ways, come up with solutions for how we can make it more efficient. And I think as far as the kata goes, that it makes sense to start everyone with basically two tests. I didn't give them names because I don't know what to name them. I'm basically giving it a full puzzle test, so it's like test puzzle number 1 is basically what it is, and test puzzle number 2. They're basically two full system sanity checks that the code works at all. Obviously then, as the person doing the kata, you could create a unit test for any smaller piece that you think is valuable. So if you write a piece of code, say, that does like get available moves or get remaining open spaces or something like that, you could write tests for those if you like as well, and those would be like little helper bits. But obviously I could write these tests in C#, JavaScript, anything, and it's great. Yeah, exactly, Phil. This is basically like the sanity check. This is the happy path, the full just check, and so everyone can see them. The puzzles I put in, I wasn't sure what data structure, but I figure almost every language has some way of representing an array structure. At first I was going to put these in strings and say like, oh yeah, we've got a string, and you could then take that data and we'd be like, oh, it's string based, so every language could use it. And I was like, you know what, that's just silly, because at the same time, every language can just implement this file and be done with it. And it doesn't even matter whether or not every language uses the same starting puzzle. So basically what I started with is these are just, lists with 9, so it's 9 lists, each with 9 integers in them. And that creates our 9 by 9 structure. And I used 0 to represent an empty space. So whether or not we want to use 0 or something else, we could obviously make these nullablants, make them null or something like that, but it doesn't really matter. So I just did 0 because good enough. I could have done -1 obviously, but as far as I know, 0 is never a valid result to have in Sudoku anyway. Okay, so when I run my tests, I put in puzzle 1 solution, puzzle 2 and puzzle 2 solution, and when I run this, I should get not implemented exceptions thrown. There we go. So there are my 2 not implemented exceptions, and that should be the starting case when anyone tries this kata. So we're just trying it together. I haven't actually gone through it yet, so I don't know how it's going to work. I think this will be a good one for people to try out a lot of different approaches to things. And we'll see. So I am going to start off by getting myself a quick little branch here. We'll call this Attempt 1. Because why not? Attempt 1, I think, sounds like a good good clarification. This is our first time trying this, and I do like the sanity check suggestion, or maybe I'll fix those in the next one because I'm already on my branch. Okay, so let's not worry about the puzzles. We know roughly what the data is that's going to come out of those. Let's hop over to our solver, and first off, just get rid of this. So my first step that I'm going to do is I'm just going to return back our input. So since it's the same structure I'm supposed to spit out as I receive, I'm going to return that and just see what kind of result I get out of my unit tests. I forget how detailed the collection assert is, and I'd like to see what it tells me. Okay, so it starts telling me where the elements differ the first time that it fails one. So yeah, values differ at index 0, 0. So essentially, because the first item in that was a 0, it fails immediately, which is actually pretty good. Because that's this one right here. It just says, hey, that was supposed to be a 4. I failed right off the bat. That's cool. We didn't do anything, so that's what should happen. So here's what, as I think through this, I can see two big approaches. One approach is I can go through every single space of this entire thing and replace all zeros with a value that's available. Furkan, so we could, for example, just console print these if we wanted to see the results. So we don't need to I guess we could toString on the object. We could write a little helper that printed them out if we need to kind of give us an idea on that. But the approach that I'm thinking about is this. I kind of want to do, for now, let's just do, for every input, we have a list that is a row. So let's change the name of input, because I actually prefer to call this the grid, because it's a 2D grid. So grid or matrix, some kind of thing like that. You know, that's our two-dimensional piece. And the next one here is the row. So for each row, we are going to have a actually, I think I want to do this as for loops, because I want the indexes. And the problems of C# not having the thing that JavaScript would get me. So I'm just going to say this is my, I'm selecting my row, so this is my Y axis. So that's the Y index up to 9. And for int, this is my X index up to 9. Which I guess I'll just call them X and Y, because that's easier. So Y and X. There we go. Isn't it just a Sudoku rather than a grid or puzzle? Yeah, I guess we could call it that. Oh, what a day! What a lovely day! Andre, thanks for the follow, much appreciated. Let's call this full puzzle? Puzzle? Sure, puzzle. Okay, so within the puzzle, we get to this point, and I want to say var options equals get valid options. What is love? Baby, don't hurt me. Hey, Stool Penner. Thanks very much for that 5-month resub. Awesome. Yes, boom chakalaka indeed. Could we get some more hype in the chat there? I know we've got a few people in here with emotes. They can put those in there. So get valid options. I think this is going to be our first helper method that we have. Hey, Kevin. Yeah, see? Thanks for that. So I want to get valid options for a location. And I renamed that. So puzzle for now. So the valid options. We want to say that valid options is... Does it take in the puzzle? It'll take in the puzzle because it's simpler if I do. And we'll say X and Y. So this is now a simple testable method that whether I keep it in here or not doesn't matter. This needs to be a list of integers. Okay, so that takes in a full puzzle. That's the X. That's the Y. And this returns back a new empty list for now. And yes, for the list of int. I could alias it. Debating whether I want to do that or whether I want to actually make an object out of it. Because alternately I could make a quick object and I could do this. And I could say puzzle. And I could make puzzle be the class that has it. And just hide it in here. So instead of doing that, I could say make a puzzle out of it. And say it takes in a list of int, and then I don't mind having that there. We'll call that data. And save that as a field. And I am going to move this onto it. Okay, so essentially then, by hiding it away in here, I can put the little helper there. Now, you might say, well, hang on, but this is still in your signature. And I'm okay with that. I have two solutions. I can either, on line 1, say, and by line 1, I mean line 1 of the method, puzzle, and we'll change this to be input. Var puzzle equals new puzzle that takes in the input. Exactly, Philip. Yeah, so that's usually the way that I like to do things, is I like to just make the local private and then extract it into a place that it actually goes. It makes it a little bit easier because then I don't have to think about where does this go at first. Whoops. I don't have to think, you know, like, hey, where do I need to put this? I can just kind of put it somewhere. And it no longer needs to take in the puzzle. It can now just take in X and Y. And what it returns back is still a list of integers. So now I can say puzzle.getValidOptions. It does not take a puzzle, because it is part of that. So we go from a static method that took in a parameter to being just another method on that object. Hangman style, list of int. Okay, so perfect. That's hidden away there. So what we need to do in order to check that is we need to look at these coordinates. What is valid? So this in itself feels like a method that we can test individually. And I want to do that. So let's make a new test file. We're going to call this puzzle tests, for lack of wanting to come up with a better name than that for now. And since I'm in NUnit, this is going to be a test fixture. Yeah, fixture. I can spell, I promise. This will be a test, and public void test1 until I come up with a name. And actually, we're gonna say should do something when something. I still want that convention. We'll rename in a second once I figure out what we're doing. So get valid options is what we said we were testing. So we're gonna say new puzzle. Yep, that puzzle. New list event, that big ugly thing. Now maybe we'll alias it in here, actually, if we're gonna use it multiple times here. So we're gonna puzzle dot get valid options. Okay. So initial one. I'm thinking empty collection should return, so empty rows and columns, it should return all the options. So if it's in a totally empty group, all 9 choices are available. Results. And I did not include collection assert are equal. Greetings, Simon. Welcome. All items. Bummer. I was hoping there was an all items are the same thing. Okay, so we'll say are equal. We'll write this differently then. We're gonna say result dot all items are unique result. So we want that to be a full set of those, and we'll say result that's a list count. I should have included fluent assertions, because I keep trying to write these backwards. All items are unique result. Assert are equal 9 and the result. So there are exactly 9 of them, and I want to assert I'm going to say assert that result dot all using link x is less than 10 and x is greater than 0. So I want these to be the numbers 1 through 9, and that's a reasonable way of making sure that they are all 1 through 9. Greetings, welcome, glad to see everybody showing up in chat. It's wonderful to see you all. Hopefully you're all having a great New Year's Eve so far. Yeah, sometimes just watching somebody else code is pretty relaxing. Okay, so do something when something. What am I trying to do? This is return all for an empty array. Okay. Should return all given empty puzzle. This is a totally crazy scenario. Yeah, exactly, Simon. Once you use fluent assertions, it's really hard not to use it. Fluent assertions or any other one like that. If you haven't seen it, I usually use it in most of my stuff. I would basically be writing, you know, result, result should be true. And like that, actually for this one, there's a special one for like should be true or something like, and this is what, you know, like the kind of code that you write when you do fluent assertions. And it's nice. So this needs to change its name because I did return all given empty puzzle. So this is get valid options. Should return all given an empty puzzle. There is our name. Let's change the name of the file so nothing gets weird. Okay, file name changed. And run a couple of keyboard shortcuts, and there we go. It very well could, Simon. So I might grab it in a minute. I don't want to see those tests. I want to see this one. Expected 9, but was 0. Perfect. So that's this. Okay, so let's write that code real fast. So if we go over to the puzzle, valid options for X and Y. Well, the simple solution. Actually, I didn't check the actual. I didn't give it the right data, but I guess that's not a problem just yet. Let's call this empty grid. There's empty grid. And empty grid needs to have, I'm going to steal the data from this one. Hang on, I see stuff in chat. I will catch that in a second. Okay, there's my empty grid. Brave Cobra, we're gonna do a Sudoku puzzle solver kata. Yeah, like S&B said. So now we actually have an empty grid here, and I'm gonna put this at the bottom. Even though it is a field, I kind of want to hide it because it's really just test data. So I want to keep it out of the way because I think the test should be at the top, and that's a big thing. So if I don't pull this out into a separate file, I don't want it taking up a lot of space. So there's our empty grid. So we create the puzzle from an empty grid, and then we take the puzzle, get the valid options, and we should get back 9 of them, which again, we're not going to. Yeah, Brave Cobra, exactly. Now you can be like, oh, I wrote a puzzle solver. It'll do it in like 5 minutes. Here, do you want the answers? And 5 minutes includes entering, like typing in the numbers. Although it really shouldn't take that long to type in a puzzle. Okay. So now, available options. What are the available options? We could just return back 0 through 9. 1 through 9, I mean. There we go. I made that puzzle pass. Made that test pass. At least I hope I did. Okay, cool. Test passes. Oh yeah, Brave Cobra, we could just read the number. We could just pull the numbers out of an image, and that would solve it as well. Using image to text. And that would be a little bit cheating. Okay, you know what? I don't want to do empty grid like this. I want to do private list of int, and I want to say empty grid get So I want a new one every time, which, yes, I know uses extra memory, but this should make testing a little bit easier. Whoops. Return new. Yeah, we could expression body it. Why didn't I just do it that way in the first place, Brendan? Okay. Yeah, S&B, we're all done. By the way, enjoy your second... explaining code reuse through subroutines is that you have not used the debugger and stepping through the code to make it clear the flow of the execution, how the state moves between the callers. So, Simon, yeah, the weird part on that one is I'm not sure how the debugging works through LiveShare. I haven't tested it, so if it works well, then I can explain it that way, but it's a little weird scenario, so it might. So if it does work well, then hey, I will do it that way, but I admit I haven't tested it, so I'm not confident that it'll work the way that we want it to, where like I could see the code as someone else stepped through it. So I know I can run it on my Visual Studio and step through the code as it debugs. That's easy. Okay, so that's the empty grid one. So now the one that's going to make our tests fall flat and prove that we didn't really make that code work. Return empty given full puzzle. Can I make a full puzzle? Let's say given full row. Wait, no. It would only return empty given filled cell. Return empty given filled cell. If there was already a value there, then there isn't one. That's the empty scenario. Okay, so return empty given a filled cell, which means I need to set this value before we go there. So I need to set the 0, 0 value. So empty grid is not what we're going to start it with. We're going to say data. Sorry, empty grid, and we're going to say data at index 0, index 0 equals 1. And then use that value in here. And we are now expecting to get back an empty collection. Yeah, so Brave Cobra, we're just representing it with 0 instead of a null. Just so that we don't have to deal with the complexity of a nullable integer. We could do -1 if people preferred, but then it messes with the shifting. So like we can look at it in this grid and easily tell where every number is with the zeros. Because also if I did nulls on here, then again everything would shift weird, and I don't want to deal with that. Speaking of just layout concerns, I'm going to do that. Alright, so now when I run this, the first test should pass still, because we cheated that one, and the second one should fail, because we haven't cheated that one yet. So here's how we're going to cheat that one. And the funny thing is, the cheat, I think, is going to stay around. Because it seems like cheating, but it isn't. It just sort of looks like it. Because I'm going to say if underscore data at x comma x. Whoops, so yeah, I didn't do it that way. I did it this way. If that is greater than 0, then return an empty collection. Okay. That should make the test pass. Remember, we're going for the simple solution that makes the test pass. because that's how you make sure you don't make mistakes. And my phone is buzzing, so sorry about that, everyone. Now it should stop buzzing. Hang on a second. Okay. Alright. That passes. That works. Yes, exactly, Brave Cobra. If we wanted to do a summation, 0 won't affect it at all. So if we want to sum all the rows and columns and make sure values are what we expect, because you could make sure they're unique and check the sum, and that's a fairly quick check. Okay, so we filled in one value and called it good. Here's what we can do. We can use the test data for our next one. Let's say return one item. Let's say only option given one empty cell. Or let's say only empty cell. Return only option given only empty cell. Okay, so Brendan, where are you going to get that data, you ask? Well, I'm glad you asked, because I have a solution for that exact problem. And I am going to call puzzles dot puzzle1 solution as our initial data, and then I am going to take that, and first off, I'm going to confirm how I wrote puzzles, and make sure that I don't mess with my data when I do that. I am going to, so let's do this. Okay, so here's the quick change I'm making real fast. You all might notice that I am adjusting these fields to instead be expression-bodied members. So these are called expression-bodied properties, and essentially what I did here is I made it so that these are getter functions that when you call them, just return back a new version of the data. Sudoku solving algorithms. Yeah, Brave Cobra, we can look up one of those later. For now, we're just gonna brute force this. It'll be fine. It'll be fine. No way it could go wrong. Okay, so looking back at my tests, let's get rid of that test. I don't care about that test. Return only option given only empty cell. So I need to go the other way. So I want to take that initial corner cell and turn it into an empty value. So I'm taking the completed solution right here. I'm going to store it in this. I'm going to reset its data. And then I'm going to come down here and say, hey, this should have one item. Is that a single contains? No. Yes. Okay, so puzzle 1. What does puzzle 1 have in it? Puzzle 1 solution. It's supposed to be a 4. Oh, you know what I could do? I could just grab the value. That was foolish, Brendan. That was foolish. There we go. Oh, and then the result, and it should contain that value. And I want to say assert are equal 1 and result.count. There we go. So I want to make sure that it contains my 4 and there's only one value in it. So should work well. The backtracking approach then. Yeah, exactly, Brave Cobra. So we're gonna do the simple like brute force, find the options, and just try inserting every option into every cell that we can, and see what we end up with. And it's gonna be messy, but it will work. And then we can optimize. We can change out the algorithm. We can try new things. But that's kind of the idea, is a lot of times whenever you're building something, you want to build the one that works. Now, obviously, you can put in little short circuit things and be like, well, I know we can cut this here, so you can make some optimizations as you go, but I like the brute force approach initially just because it's a simple way to go. Now, obviously, you can go look up an algorithm, do it the way the algorithm says, and it will work fine. This test expected 1, but we got back 9 results, and it did contain my 4. Because it included all the single-digit numbers, except 0. Okay, so inside of puzzle, we need to actually see what these values are. So let's do it correctly-ish. So, rules of Sudoku. If you actually haven't played Sudoku, the quick explanation is every given row, so that's one of these right here, for the puzzle to solution, there should be only one instance of each number 1 through 9, and in the column, so like this, there also should be one instance of each number 1 through 9. In addition to that, every 3x3 box, so it's three boxes across, 3 boxes in the middle, three boxes on the bottom. So essentially making, 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. Each one of those boxes should have 1 through 9 in it. Correctly-ish. Yeah, Brave Cobra. Correctly-ish. Okay, so that's the basic idea. So when you insert the values, you try to get it so that you can have all the numbers represented. Okay, so what we need to do is we need to find out... so first off, I might save this as all numbers. And maybe we'll constant or put that somewhere for now. I'm going to let it live there for the moment. So that is a read-only private list of integers that I'm calling all numbers. And I want to say return all numbers except the ones that are in the row with us. So get rows, get column values, and then accept get row values. And as I said, we're brute forcing it, don't worry. Get maybe block values. Is that a block? Is that what we're gonna call that? I don't know what it's called actually. So I'm gonna do these quick checks, and for now each one of them is just going to return its own value. We won't worry about that. And welcome, Charge. Thanks for that follow, much appreciated. Get values of box 5 as a list. Maybe use an accessor to read the values of the boxes. You're talking about in the like the blocks. Yeah, we got to come up with some way to do that. For now, I'm just doing this. Return new list, and last one is return new list. Okay, now I am not going to individually unit test each of these, and I realize that probably only actually needs to be an enumerable, but I'll leave it as the list and just to-list this at the end and not worry about it. So we'll just to-list that. Whoops, stop. Okay, so again, it should still return back all 9 options. Hey, Johan, welcome. Okay, expected 1 was 9, so we're still pulling back the whole set, no problem. We can absolutely fix that. So let's check the row values first, because that seems like the easiest one. So what a lovely day! Welcome, thanks for that follow, by the way. Underscore data dot I needed to pass X and Y in here, so that's Y, that's X, and this needs X and Y in order to know which block we're in. Int, we're going to call that Y, int X, and this is int X, int Y. Okay, so we're going to get the distinct values. We're already ignoring 0, so by doing these accepts, I don't actually have to ignore the zeros because I'm not returning out of these sets anyway. I'm returning out of my all numbers collection. So because of that, I don't actually have to worry about the zeros when I do this. So return that dot distinct, and then it makes that one super easy. Would the reverse be more difficult to Sudoku generator? No, Brave. Well, it depends on how solvable you want it to be, Brave Cobra. Because I think you could just randomly put in numbers and create a full Sudoku puzzle, and then remove data from it. So I would create the solution and then remove data to create the actual puzzle if I were doing a generator. But yeah, so if I were doing it based on the difficulty, I would actually want to analyze the logic that people use and apply specific types of removals of data to that. Okay, so the column values is going to be weirder because I want to get the distinct ones. Well, they should be distinct all the time, aren't they? So I don't need to distinct it, I can just return them. And on this one, I can say for I up to 9, I can just say underscore data I, and return back the, wait, get the column value. No, this is an X, this is a Y. Derp. I almost derped my letters there. You get a column based on your X value. You get a row based on your Y value. Derp. I almost totally derped that. We would have figured out when we got to the test that hit that one, but I almost derped that. Hey, Zultralord, welcome. Okay, so we want to go through this, change Y each time, maintain the X as a constant. And I'm going to yield, not yield, break. I'm going to yield return these values. I don't even need that because we're not breaking early. We're just finishing at the end of the method. So, okay, so that'll get me back my values, and we'll just do it like that. The ceiling is up. Yeah, good. Glad it hasn't fallen down. Okay, so the last one is I want to get the block values. Well, let's see if our test passes. First off, row and column should have been actually just rows should have been enough to get us this last value. Okay, it did. Let's do this. given I want to fill just one row. So return only option given I want to say given full row, and then I want to do given full column. So I'm just going to do a quick for loop, because I think everybody will be able to understand this. There's nothing weird about it. Actually, let's do 0 through 8. And actually, let's not do that. Let's do 1 through... There we go. We'll start at 1, filling in the values. So we're filling in a row, which means row 1 is getting it. We're filling in at I, and we're going to put in the value I plus 1. So essentially we're going to put in 2, 3, 4, and 1 is the value that we expect to get. So, yes, I'm aware that I'm making an invalid puzzle, but that's okay. So we're going to do that, and instead of this value, we're expecting it to be a 1. Because we're going to check at that location. We're going to fill in everything except number 1. And that should work. I think this works right now. I'm going to remove the row checking column just to be sure that this is the one. Okay, so it's passing. Now, remember, red-green refactor is important. And the reason is that because I wrote these two and they both made that pass, I need to confirm which one it is that did it. And so, I'm going to do this. I'm going to return that on this method. So get row values is now going to do this, and now the test should fail. And I just want to be able to confirm that our row check worked, because I don't have an individual unit test on that method. Okay, so it fails now, which means that it is coming from this one, I believe. So we'll put this one back. And should still, whoops, should pass now when it gets this value. I got ahead of myself on that test because the all test was a little bit too easy to make pass, and so that's why I want to do the column and the row defense here. Given full column. Brave Cobra, I wasn't going to make an isValid method yet, but I will need one before the end. So I am going to need an isValid method. So I will write one of those on the puzzle, because that's how we're going to verify and bail out that we're going to be able to short circuit a lot by doing that. And that's also the only way that we can check that we got the real answer when we're brute forcing. So we'll have to check that. Okay, so this one, we're going to be doing I there, and then this value becomes 0. So we're going to insert the other way. So we're going to fill every value. We're going to change columns and do every x of 0 with another value. Did I uncomment that code? I hope not, because otherwise I'm just going to have to run my test multiple times. Good. The test failed like it should. Delete that and uncomment this, and we should all of a sudden have a passing test. But yeah, I really love all the questions and comments and everything from everybody, because I really am trying to figure out how we want to do this, Kata, because I want to make sure that we get good instructions and make sure that there's not too much complexity at different points, and if there is, figure out what stuff we can put in, because it's possible we want to provide a couple of things. Brave Cobra, I was planning iterative, so I was going to be sure that we finished it. So I was going to shove basically breadth first search the thing, essentially, filling in, breadth first? Depth first search, filling in everything, and trying to get that working. Okay, Okay, so that was given a full column, and then the last thing is, I want to, so I want to do a row and column combined, and say only ones between them, and then one for the block. So let's do this. So except for 0, 0, let's do this. We're just going to put in both pieces. And I'm going to have to think about whether or not this is going to be correct or not. Return only option given combined row column data. Okay, so what option do we want it to be? Right now we have been starting these at 2, so and yeah, Brave Cobra, I'm aware that's not gonna work out right. Well, actually, I am going from 0, 0, 1, and then 1, 0. I've left 0, 0 alone, so 0, 0 should still be empty and should be 1. But I don't want to do these full lists. So I only want to do... I want to do fewer of these. So we're going to start this one at 5. And this one's only going to go up to 5. But it's not actually going to get to 5. So this is going to do 2, 3, 4. So 2, 3, 4, and 5. And then, yeah, roughly speaking, the number 1 I believe is going to be left alone here. And should come back. I think this test is going to pass. Okay, good, it did. So let's try this. We're going to remove one of these, replace it with a return of an empty collection. And now it should fail, because we should have too many items in the collection. Because we should have either ignored the row or the column. So that's this one. Expected 1, but was 5. Yep, okay. And actually, if I switch it, we should end up with the same kind of result. If we make it be the other one that has that. Then I think it should be accurate. Yeah, did the same thing, 1 and 5, so perfect. Good job, thank you, thing. Delete that, uncomment these. There we go, perfect. So our red-green refactor is working. We did our initial, so it definitely does fail first, and then, so it can fail for the right reason. I'm going to assume that our accept works correctly for the other one, and I'm going to quickly make a block that I think will give us the result that we want. Because what I'm going to do is, let's let's do the blocks. Ooh, man, I'm not sure how I'm going to do the blocks yet. I'm going to have to figure that one out. Let's return available. Given actually, I say only option. Yeah. Say given full block. We're gonna do an only option given the full block. So no accept value for a cell. What do you mean by accept value? Like check to see whether the cell can accept that value? That's kind of what I'm doing with get valid options. It's getting which ones can be in that. So you could never put an invalid one in because we won't offer it. Yeah. Hang on a sec. Would this be easier to visualize if you could override parse and toString so you can draw the test data? Simon, I can draw the data, but I mean this is kind of like I can do this to sort of illustrate to people a little bit, make this a little bit easier to see. What's that going to do with those? Oh, that wasn't a problem. Right, and then there's basically the test data that we're dealing with. Whoops, when we do these. So those are our blocks that we're working with. Get valid options is kind of the opposite. Exactly, Brave Cobra. I'm returning back which ones are available for that cell. So in this case, I'm gonna fill this except for that one value, just this corner value, and hopefully figure that out. So how do I deal with these? How do I separate that? How do I logically think of a block? How do I know which block I'm in? Mod 3 in both directions. No, that doesn't get me that. Divide by 3. Divide by 3 in both directions. Drop the... Yeah. So divide by 3 and then multiply by 3 to get the base of the grid. Okay, so here's what I'm thinking. I'm thinking through how to define each one of these sections just to make it clear. So if I say have the way that I find that, so if I have this block, that is at x 0, 1, 2, 3, 4, so that is at 4, 1. So 4, 1. So 4 divided by 3 would give me a value of 1, and then times 3 would get me that index, would get me the 0, 0 of that, right? So 4 divided by 3 equals 1, which gets me this value here. So I can then say 1 times 3, that gets me 3, so 0, 1, 2, and 3, that gets me this spot here as the corner. For the 1, I can do actually, let's do this. Let's write these in the same line. And we'll say 1 divided by 3 equals 0, and that means that 0 times 3 equals 0. So that gets me that I'm in this position. And I can then do a nested for loop of I equals 3 to get that. Does it need to be an XY array? Why not a set of 3x3s? That's a good question, Simon. We could do sets of 3x3s. Going that route, we would still run into problems with checking rows and columns, I would think. Yeah, full object-oriented programming. Maybe name index your blocks from left to right, top to bottom. I could. I need a translation from an XY coordinate to a block. Is kind of the idea, and I'm thinking this approach works. Let me see what it looks like to get that. So in a puzzle, that's get block values, right? Which is right here. So this is get all values in my block. Let's say block X equals X divided by 3. Let's do this. X divided by 3 times 3 will get me the origin, the X value of that, and then my Y value is this one. And then I can do a 4i to 3 and 4j to 3. And call index. Then I can do a yield return on underscore data, and it is, I choose row first, so row first plus row index, and then X plus column index. And I think that works. Let me get my let me get that. Let me check chat real fast. Block 8 would be the middle bottom one. Yeah, the challenge is I need to know how to get to that though. Give a cell a block coordinate as a drawing point. Yeah, effectively, I'm finding the coordinate within a block. I'm treating the block as a 3x3 once I have its starting point. So I'm taking whatever the value is. This should reset me to the block's origin, and then this will spit out all the values in that set. Let's test it real fast. So in order to test, what I'm going to do is I'm going to do this. Comment that out. I'm going to return back new list. So we're going to do the empty list again. And then we said that we were going to do this. Return only option given a full block. So I need to, how do I fill up a block? You know what? I need to go up to 3, so less than, so we're going to start at 1. 0, 1, 2, so we're going up to 2, right? Going up to 3, because I want to put in 3 of these. And then we're going to nest this with one of these. J, oops, and J. This is going to 3. So I, J, fill in all the values. What is this? Less than 7. Surely it's more effective to hold this as an object state initial sequence rather than a computation. Yes, Simon, I think I'm going to. I was just trying to avoid having to have a whole bunch of these. So we're going to say filled cell. 1, 2, whoops. 2, 3, 4, 5, 6, 7, 8, 9, and this is filled block. So this has many full solutions to this puzzle, but there we go. A cell should be an XY point as a block. A cell should be an XY block. Oh, so have the XY and define the block. That gets difficult then because you still have to find the block. You could potentially store the data that way, but that's... and yes, that is true. I am not. This is not trying to be performant yet. We are just brute forcing it. We will do more performance-based approaches later. I'm just trying to think through how this works, and I'm debating whether or not we should, give more, like whether we need more test cases, which I'm leaning towards we do. Need more test cases, even if they're not, like more test data, I should say. So, we'll see. Okay, either way, the test does seem to work for that, because it did pass. And root guy, yeah, Emacs is a valid alternative for text editing. I have VS Code running right behind me in case I need to jump to it for anything. So you'll notice the that is right here, same code. In case I need to switch over to VS Code, I have it right there. Alright, so we clearly get our options. So that gets us our valid options. We're pretty sure this works. I'm pretty sure this works. So that should get us back what our valid options are. Inside of our puzzle solver, I'm actually feeling like solver just needs to call, like put it in the puzzle and just call solve on the puzzle. Because, hey, you know, this is C# and I put stuff in objects in C#. Puzzle now has a solve method. Because why not? We'll get valid options and we will return back data. Hang on while I switch drinks. Yeah, so the challenge, Simon, if we go that route, we end up having to have a lot more information on a cell than I think we really want to have. I like the cell just being the number, and the reason for that is that by taking the approach where all you receive is an array, it would be easy to write this same this same scenario for various languages. It doesn't have to be C# at all then. You could write it for any language and set up the kata, you know, with like choose your language essentially, and anyone could follow along as long as we keep it simple. As soon as we start adding any extra structure to it, we start to make it so that, you know, you actually have to maintain those separate sets. If realistically all they're receiving is like a two-dimensional array style setup, then it becomes pretty easy. So, okay. So the simple solution that I can think of is like the brute force options. We get all the valid options, and then for each one of the valid options, we try we try solving a. Do we solve the puzzle again? Ooh, that's a good question. Do we solve the puzzle? Yeah, that's what I'm thinking, Brave Cobra. What do we want to create? So my concern is if I start modifying this this array, then we run into a problem. And essentially that problem is that I don't want to be modifying the array as we go, unless I'm inserting the new option in each time. Oh, I guess if I insert the new option in each time... No, because I need to reset back to it. That's a good question. I don't remember how to do this, so... Copy list in C#. Yep, clone a generic list. That's what I want to do. Where I clonable? Wait, what now? What? Create a new list from the old list. Oh, I can just create a new list from the old list, and does that actually modify the array? Yeah, so let's do what you guys suggested. So we're gonna make private try solve list int grid data. This is going to return back a list of int. Back valid options. So if options is empty, it's a list of int. If there are any options, do that. Hang on. So we're gonna make a new list of stuff, and or alternately, what I could do is this. I could say grid.select. Oh,
what a day! What a lovely day!
This is a new list event using x.select. Really shouldn't have used x there, should I? So x needs to get renamed to y. Is that all I needed to do? Okay. Fill in the first non-zero value and call try solve recursively. You mean fill in the first zero value and call try solve recursively. And call is valid to bail out. Yeah, that's actually a good idea. So I want to copy the list first. Because I don't want to run into a problem where I'm writing in values and run into an issue that way. So when you call try solve, we want to do this. Except we need to be getting valid options of that data instead of that. Son of a gun. Get us all the options. Alright, here's what we're going to do. I'm not going to bother with having that data just yet. We're going to make that static, first off. All numbers is now static. And the reason why I did that is because I don't really want to just grab a new one each time, because that's annoying, because I'm already going to do this, which you guys are going to kill me over. When you create a new puzzle, we're going to give you the data as an entirely new set of data. So we're going to copy it when you create a new puzzle object. Yeah, so that gets us our data when we create a new puzzle. So all I have to do is on each one just say try to solve it. So we don't need this anymore. We can just use that one because solve is going to be try solve. And we just need a way of setting a value on it. Void set value at an int x, int y. And I'm just going to say underscore data y x equals number. And actually, just to make it nice, we're gonna return back the puzzle when you do that. And we're gonna call this with value. Just for the convenience of the call. Okay, so now by calling it this way, whoops, not data. This is going to be this. Okay, so now what I want to do down here in our solve is I'm going to say, if we had any options, actually we should for each it on the options. For each option, we're going to say, new puzzle var puzzle equals new puzzle using our set of data right now with value x comma y, and the number is option. So there's our puzzle, and we're going to say puzzle.solve. Return the solved puzzle? Yeah. Okay, so at this point, we could then at the beginning of the solves, say if is valid, right? If is valid, return, and this becomes our break essentially. Now, what do we do when we don't find one is the question then. So clearly this is the break we want. Turn false for now, because I don't know. We haven't gone through that method, but we need an is valid method. That shouldn't be that hard to write. It would just be check each row, check each column, check each block. Check each row, check each column. Which actually, now that I think about it, this is not hard to write. Hey, Will, welcome. Simon, it might make it easier to clone, but I don't remember how to clone a multi-dimensional array, whether it would do it the same way. You have to step through multiple iterations before you know it's invalid. now that I think about it, since we assembled it in a nice way, Happy New Year to you too, Fuel Snable, and welcome. Simon, you might be right, Simon. How do we check that it's valid? We need to say, we'll check to see if it's invalid at all. Actually, it's only valid if we can't disprove it. So the default is going to be return true. And we're going to say if so let's check the rows first. For each row in the data, Prevent pattern steps in so you can undo the option value. Oh, I wonder. I do wonder how it works, Brave Cobra. I'm looking forward to seeing that. For each row, if row dot x is greater than 0 and x is less than 10, dot distinct dot count is not equal 9. Did I write a... I wrote get row values. But get column values is going to be useful. So it needs to be between 1 and 9, all distinct, exactly 9 distinct values between 1 and 9. Will, I believe I have actually sent out that invitation, but I did not get a response, so I may follow up with him on that one. Yes, there will definitely be some F# in 2019. Don't worry, don't worry. Get row values should not have duplicates. Yeah, get row values right now does allow duplicates. That's just what's in there because we can have duplicates on the zeros. It shouldn't ever because we should be being cautious about this. But if we ever got an invalid one, there would be a problem. And actually, is valid is wrong. I should say is complete. Is complete, return the data. Otherwise, we don't want to throw necessarily, do we? one of them should finish.
Oh, what a day! What a lovely
And
day!
welcome. Thanks for that follow, everybody. Yeah, sure. We'll throw that down there because we're definitely not to that point yet. So for 0 to 9, we're gonna say var column equals this dot get column values for I dot distinct dot and we're about to see that we're going to have the same method duplicated, and we're going to need to extract that. And I'm going to guess K Hero, but if I totally butchered your name, I apologize about that, and try and tell me how to say it better, and I will try to say it better. But welcome, greetings, hi. Strange how I got the algorithm visualized in my head. Have a look at that GIF I posted. But okay, so this one is that. So that's check row, that's check column, and then we need to check block, which really just means get the block values, which we already wrote as well. So that's get block values. So for each block, how do we get the blocks? Because the way I wrote that, there are 9 blocks. So we're gonna say x to 3 for y to 3 var block equals get block values of x times 3 and y times 3, and that'll be the corner of each one, and the math checks out. So that should get me all my blocks, and I'm gonna say the exact same code I did down there up here. Block here's where it's good to extract. So let's extract this code first. Shift R, that is a method, and that is going to be a method called isSetComplete. Or if set set's not complete, we'll do that and return false. So this should take in block. That should take in row. For each one of those, we should do that, that. Otherwise, return true. Hey, I got it. Awesome. Glad I didn't butcher your name. Yeah, it is. I appreciate it. It's easy to butcher names, so I never intend to. So I'm glad I got that one. Okay, so looking at that, we get the block values, we get that, turn true. Okay. So we're saying if is complete. Is complete, return data, there we go. Puzzle. So if we ever get a complete one, we're going to step through this, we're going to get the valid options, we're going to call solve on the new object that we create with those values, setting that one. Alright, well, I don't know what's going to happen yet, so I'm going to run this test. It's probably going to fail, maybe we'll get caught in an infinite loop, I don't know, we'll find out. Only one way. And, Ender Savage, hello, welcome, greetings. Not that anyone asked, but I am writing a screensaver app. Nice, Fuel, nice. We might be caught in an infinite loop, I have no idea. Ooh, test not run. That probably means that we, like, ran out of memory or something else ridiculous like that. Sunspire, thanks very much for the biddies. Hype in the chat. Thanks for the stream. Good to see how Pro works out logical yeah, it's a weird one. So, like, we don't usually solve these in the wild. Like, most of the time we're not solving a Sudoku puzzle. But I'm trying to balance, like, which pieces we should be testing here. So, I'm going to do a quick is complete check on one of our solutions just to confirm that it works. So class is complete should, and I'm going to make this a test fixture without those. And then in here, I'm going to say test public should turn true given sample solution. And then I'm going to turn false given sample puzzle. So I'm going to say new puzzle from puzzles.solution and say assert true puzzle. Did I make that? I think I made it private. I'm going to make it public just so I can test it. Yep, that's right. For katas, I am willing to do that. Just say make it public. Normally, you gotta find other ways around that, but in a lot of katas, you end up with like, oh, I really want to test this piece. There's not a great way other than public. Fuel Snable, you have a friend with an 8-year-old kid that has some interest in programming. There are a lot of answers to that. There are a lot of like kid-based approaches. I think code.org has a bunch of them, and other things like that. Plenty of things out there. Like a lot of them are usually more kid-friendly and like cartoony and things like that. So it's like a lot of like the logic to move a character around, and that kind of gets kids thinking about the sequential logic of programming. Aside from that, you could work with them on just some games and things like that. So build some stuff together, something fun. Make little stuff. That's probably the answer that I would give there. So this one should be false. Whoops. IF, and that is going to be puzzle 1. Yes, exactly, Renee. That's how you do it elsewhere. That's why I was commenting, like, right here, I'm just going to do the public. Okay, so our is complete seems to work. It does verify that is the correct one. And just to confirm, that it's going to catch an invalid one as well, given invalid let's say invalid solution. So I want to take puzzle 1 and say with value at 0, 0, we're going to put in the number 9, which I believe is not value of, whoops, I meant solution 1 at that point. So we're going to alter the value, get a new puzzle, and check that. And it should not be complete then. I copied the correct one, right? False. Yes, I did. Okay, cool. So it seems like it checks it. We get back our trues and our falses as we expect them to. Scratch to start, small basic of advanced. Yeah, so Simon's suggestion of using Scratch, that is a really good place to start. I'm gonna... Ooh, man, you got a tough name. Maybe Nomi Und? Nomi? Hello, welcome. Hey, Nomi. Greetings. Hopefully everyone's having a good end of your 2018. And thanks for that follow, by the way. Much appreciated. Just try to guess on the names. If I butcher them or if there's a short nickname that's easy to say on a stream, let me know, and I will go with that. Okay, so that does work. Let's get those out of the way. So that's a reasonable way of testing that. So let's walk through and see what happens in the big test. So debug this. I want to just see how it's working, how close we are. So we come in here. We go to solve this. We create a puzzle right here. Yeah, thanks, Will. Appreciate that. I mean, W. May the new year be with you. The kid is into crafting, building, painting, etc. So I thought perhaps there's some good tools to combine, say, building something with adding programmable lights to it. Oh, that's an interesting concept, Fuel Snable. You could definitely look into some things that you could do with like a Raspberry Pi or something like that, where you build an interesting thing together. There's definitely some approaches there. Okay, so let's stop there. Let's stop here. Okay, so we get to this point. We have 0, 0. We should have 3 options, 3, 4, and 5. What's the data on this one look like? This is puzzle 1. I want to take a look at the data. So that's this one. So we're looking at this position, and we're saying 3, 4, and 5. I can just glance at that and tell you 3, 4, and 5 seem like the choices. And then once we get those, we come down here, and we should be creating our first one and trying it. So this should be the version that inserted the value at 0, 0. 0, 0. So it inserted the 3. So that's this one. Now when we get to options, we should end up, we skipped past it, we're now at x equals 1. We should have a different set of options. We said no options? No options. Because 3 must have been a bad one to use. What's get valid options coming up with? All right, we're searching get valid options. We're gonna take a look in there because I thought we were gonna get back some results in here. Let's take a look. We're gonna take a look. X2, Y0. What's my data at that position? There's a 1 there. Okay. Okay, here's what we're gonna do. We're gonna get a little helper. You guys convinced me. You said it a long time ago. You were all right. I was wrong. I can admit it. Someone asked me right at the beginning, are we gonna make a little to list to help us out here? And I guess we should. So we're gonna to-string this thing, where we are going to for each underscore data, that's a row, we're going to for each row, this is going to be a cell. So for each one of these we want to print this out. Actually, we don't need to do that for this. We can print out the row at a time. So we're gonna put together a space separator, and it's going to be the row. So we need this to be a single string, so we'll do this. We'll make a string builder. We will append this on sb.append. Whoops. Append on that. And return sb.toString. Okay. And yes, you are correct. String join, and we'll do an sb.append line. There we go. Wait, can this do the line at a time? String value. Yeah. Do that. Cool. Alright, so that should to-string it. Just do it as a big string interpolation. I technically can, because I know the size, so I could actually hard code in a full interpolation of that. Which would really be hilarious, but no, that sounds really, really ugly. But I guess I could format it nicely if I did it that way. Let's see what this ends up with. So when we get into the puzzle solving again, unit tests, debug. Oh yeah, I guess I could just do those and do a string join on that. They would work the same way. Okay, so this dot to string. What gets printed? Oh right, because it's new. We're doing new lines, so it gets formatted really poorly in here. Fuel Snable, he might be on the list of people that are to be invited on the stream. Let's do this. Console. Whoops. Console.WriteLine. ToString. Let's see if that works. Each time, so that's gonna be a lot of writing. So like, we're not gonna want this in here when we're not debugging. So I guess I could make it so that only happens in debugging. Is it debug where that's going to come out? Or maybe I have to debug print it? I don't remember. So we should have written that to the console one time. Debug dot print that message. Unit test. Debug. There we go. Hey, got it. So that's not terrible. So now when we get this, we should be running our next puzzle. We come in here. It's not complete. Let's put that there just so we can see if that ever gets hit. Our valid options. We said there weren't any. So we inserted a 3, and we're checking 0, 0, so there shouldn't be any. So that means we go to the next one in the set, which should be looking at 0, 1. Options. It says there aren't any. And there's the problem. There should be. I think. Let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Never mind. We're out of options. Holy crap. We were legit out of options on that one, which I think means we get to our throw not implemented exception, don't we? Okay, so here's what we're gonna do. I'm actually gonna do this. I'm gonna print solving puzzle. And let's put a new line at the beginning of this. Alright, let's take a look at this data, because it shouldn't change until we call into the next puzzle. Oh yeah, Simon, that could be. Whoops. I should new line here too, shouldn't I? Derpy derp. That looked bad. Now when we look at the debug output, what do we get? Solving puzzle, there we go. Okay. So for 0, 0, we know that 3 is wrong, but it's going to try it. So it's trying to solve the 3 puzzle, and it should quickly figure out that that's stupid. And then this one runs, where we have set some other value. Now we've set some other value. Really, we should be able to finish each row. If we cannot finish the row, then that's the problem. Brave Cobra. Well, that's a pretty good countdown. But I don't think we're going to start from an hour and 45 minutes. Seems like a bad countdown timer. Hang on. Someone's gonna kill me for this. There's a way to tell it that that value exists only if this one, but anyway. True and the data. And then this one is return false. False. And I guess the data for no reason in particular. We return the puzzle.solve on that, and then choose her.
Oh, what a day! What a lovely day!
If attempt, what do we want to call that value? Success. Then return attempt. If it didn't, then we're just going to try inserting the next value over top of that. We only return it in here if it's a success. Otherwise, we're going to get to the fact that it wasn't successful, return back a false, and not continue on. Okay, I think that makes sense. Hey, welcome, Epic. Thanks for that follow, much appreciated. Just so you know, your name is pronounced W, not double U. Got it, Will. Your name is Double U. If the new value leads all invalid puzzles, then the value is not correct and go to the next value. Yes, exactly. Yes. Yep. And in fact, at the end of a row, we could check to see if the set is completed or not, and if not, basically if we left anything as a 0 in any row that we're passed, we could fail out, and that's actually probably what we should do. But we're going to brute force for now. Let's try this real fast. Whoops, sorry. That'd be the first solution we'll just return back from this side. In our solve method, we'll just assume that try solve works. Let's see, does this work? I don't know if this is going to work. We could get caught in an infinite loop for all I know. Should you not break and trace back when we encounter a cell with no options? It could. So no options can just mean the value's there, Renee. It would be if there were no options and the value's not 0, then we should just skip to the next one. But yes, that's a very good point. So let's put in a couple of shortcuts, because I'm not sure why that didn't finish. Which actually, now that I think about it, maybe I should just debug without the breakpoints and see if we're getting an error. Whoops. I can't run it that way. Let's do this, debug. We'll remove all breakpoints and just watch and see where it crashes. That's going really slowly if that's how fast it's going. Maybe that debug text is worse than I thought. Maybe we're hitting like a time limit on the test, like the test says, hey, you can't run for more than 10 seconds or something. Hey, Stack Overflow exception. Cool. Congratulations, everyone. We got a Stack Overflow. That's pretty good. Yeah, you can totally get Stack Overflows, especially when you're doing a recursive approach like this, where we're just creating the next thing and calling down for the next one each time. Yep, put it in production. So here's what we're going to do to try and prevent that a little bit. We're going to say, if there are no options, then return, and the value is a 0. If options, any, if there aren't any options, and underscore data y x equals 0, return false. And you know what? I guess the value is going to be, you know what? It should be null if it's false. We don't need the data if it's false. We only need the data if it was true. So there's the first short circuit, and it's a very simple short circuit there, which maybe that can get us to the point where we don't Stack Overflow now. Hey, there we go. Okay, we got back null. That's dumb. Because we expected to at some point get a true, and we didn't. We only ever got falses. So let's take a look at this code. When did we return and why? Did I write that wrong? If there weren't any options, there were no options in the values and return false. Because it's on the first one. Because it's on the first attempt to do this. Because the first time through, if we inserted an invalid value, like we didn't have a value, we'd return back false because we'd messed up on the first one. It's true that once we hit the scenario, we've created a bad one. We should never be altering the current one, though. Is this the initial one? Try starting with an empty one. That is a great question. Can we build an empty one? Let's try it.
Oh, what a day! What a lovely day!
Get valid option should. I'm going to move this into the puzzles file so it's not here. So this is going to be wrong, but let's see what it gives us back. Does it give us back null or does it fill one in? That's my question. Zapsody, hey, welcome, greetings, thanks for that follow, much appreciated. Brave Cobra, the test one I've got I know is solvable. Yes, Renee, YX is the order. YX is correct. Y is the row, X is the column, so yes, yep. Empty grid must just get too big and Stack Overflow immediately. It shouldn't go through all that many options, but maybe. I could be wrong about the number we go through. I run just this test. Yeah. So we get back, we expected that, we got back null. That's, which is annoying. Okay, so I believe it is a result of these. Let's go run this real fast with a debugger attached and see. We should return false a whole bunch of times. But is this first return false the one killing us? No. it is. What? Puzzle. Solve. So we try to solve the puzzle. When we solve it, it should have options for every value in there. Always. Because we don't alter its data. Because when we create a new puzzle, we should be making new versions of the data, right? There's the test we need. We need to confirm that this really is new data each time and that we're not altering the original list. I'm not 100% that this is actually doing the copy I think it is. So the new data object should be the previous array I'm going to be completely insane here for a second, everyone. Just ignore me while I do this. That's going to be our Y value. This is going to be our X value. I want to say that's a new list. And then I'm going to say this dot add a new list for each row with a capacity of 9. Which actually I don't even need to do that. I can just then add them and say data at position Y. Add in data Y, X, and we will create a whole new frickin' thing, and I will be absolutely certain that those are just integers. That is a new data set. I'm not modifying the existing stuff. Nothing's gonna survive that. Simon, that's a reasonable approach. This should effectively do the same thing. That should get me new integers for each one of those, creating entirely new collections each time. And then we're just going to get the test inconclusive thing because I stack overflowed the test again. So there it goes. Was null. So we borked something in that logic. We get back the null here, and if we continue this, we check the next one. So y equals 0. Wait, hang on. Y equals 0, x equals 1. Why are we always doing y equals 0, x equals 1? Why did I call that like 3 times? Y equals 0, x equals 1. When I get down here, we get so we get the options for this. We set the first option. So that should have set the first value. Right? So 0, 0 should have like a 3 in it now. A 4. So for the second item in here, 1, 2, 1, 2, 4, 6, 7. Whoa, why, okay, so I tried to solve it for 3, and then did I bail out? Oh, now I'm trying to solve it for 5. Okay. So I tried 3, 4, and 5 each as the initial values, of that first puzzle. Is that puzzle wrong? Did I do the wrong value? Yeah, it's a blank in the first one. What type is it returning? Anonymous type 2? We're returning a tuple right now, Simon. So it tried inserting a 3, 4, and 5 in there for those values, and then determined that we'd failed when it couldn't get one into here. Now, what I don't understand is this. In my code, so I think it's the short circuit that's killing me right now. And that's why it's failing that way. But otherwise, I think we're getting the Stack Overflow. Yeah, and then this keeps going until we eventually Stack Overflow. Case, does every return give you a non-null tuple before you attempt to access the member? Does every return give you a non-null tuple? I would think so, but hang on. I kind of want to say if data y any I'm going to put in that short circuit and see if that's enough. Basically saying if we hit a row that we couldn't finish, like we couldn't find for some reason there's a row that's invalid, that we cannot actually get all of its items, we want to bail on that attempt because we could not solve that. Because there was a row that we left one incomplete on. I have the debugger. Nope. Turn those off. Let's see if we Stack Overflow or if we just get an invalid result right now. What happened? It didn't solve it? It bailed. What? Okay, bring these back. Debug this again. When you return attempt, does that convert to the tuple correctly? Yeah, it should. It's this. It is the tuple. It's the same return result that we have that we're sending back ourselves. So let's find out when it hits that, because I assume it's hitting that and bombing. It must reach the end of a row and say, hey, we're done. We can't solve this further. I can't imagine that it isn't. And then we stack overflow. Do we never get to that check? Maybe we don't get to that check. Are you reusing the data that we return from solve? Are you reusing the data that we return from solve? Brave Cobra, I'll need to have a look. I think that there's something wrong with our basic loop, because this puzzle solving is stack overflowing before we get down to here. So we are bombing before, like, I don't even get to this. So we bombed something here. Something's wrong. We need to track down what this is. We did something stupid somewhere. And yes, Andre, I think we're checking the same solution over and over and over again. So when I suggested long ago that we might be catching an infinite loop because I hadn't really made sure that we didn't, I think we kind of lost sight of the fact that we could have been doing an infinite loop. So let's do this first off. So this is going to get ugly, and I apologize for that. If row is complete, what did we call that? I think I have is set complete, and we'll say this get row values for y. So we're saying if this row is complete, then continue. So just get to the next one. So that means this row is done. Don't check it again. Clearly I know we're not there yet. Obviously, if underscore data at y x is greater than 0, then we just want to continue. We're just moving forward. We don't need to do these values. So these are short circuit. Don't even bother looking for anything if you've already got if you already have a value, just move on. You're already done. And yeah, Simon, I could just comment it all out and build it back up to make sure that we didn't screw something. Like, we did something stupid somewhere. I'm just going to put in a couple of short circuits here and just see how free... So this one we should hit all the time. Let's see what's going on. You know what? I want a simple puzzle. Hang on. I want to solve a simpler puzzle. Instead of having a solver, I'm going to make a new puzzle. I'm just going to do this. And it's going to be puzzles... puzzle 1, oops, puzzles Puzzle 1 solution. So I'm going to create a puzzle from the solution, and I'm going to say with value 0, 0 of 0, and then dot with value what do we want to do? 1, 0, 0. Okay, so that's what we're gonna do. Hang on, we're gonna put these like this, and then I'm gonna do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm gonna zero out the top row, and then we're gonna use this puzzle. So I'm gonna say puzzle.solve data. And that's gonna be our solution for this one. We're expecting that to equal puzzle 1 solution when we're done. That should clearly be the only option. This should be the simplest one to pass. We probably should have started with one of these ones, and we got an index out of range exception. Because I did 9, which I shouldn't have done. There is no 9. Derp. So this should be the simplest one. We fail with a null. So see, there is something there's something wrong when that first one can't work, because it really just needs to put in the first row of 4, 3, 5, 2, 6, 9, 7, 8, 1, and that's what it needs to put in. There is only 7 of 9. Thank you, Brave Cobra. Okay, so which breakpoint do we catch first? A continue on this for yx. Wait, at 0. What? Wait, hang on. Wait. That first row. I didn't zero out the first one. How did I not? What? Oh, no, we inserted the 4. Okay, never mind. We're good. So we skip it. We did a continue here, which should have skipped past that. Oh, and then we don't need this anymore because I already put this skip in place. So we don't need that short circuit. So that's the problem. We don't need the short circuit. I short circuited here instead of there. So yeah. My bad. I had both catches there. Alright, now we can debug this and see what the heck is actually happening. Herp and derp. Herp-a-derp. Okay, so we do expect our second. So the first time through the loop, we did 0, 0, 0, 0, and then we did 4. So we inserted in the 4 that we knew was all that could go there. We get out here, we said the row is complete, so get to the next one. Wait, why would we say the row is complete? Wait. Stop. Why did we say that row is complete? Hang on. That's a lie. Did I? Oh, I might have transposed row and value. That could be why. Yes, James, this is Sudoku solver. Is set complete get row values. Yeah, we said the set was. We said that. I needed a breakpoint out there because I need to see, did that actually run through it 9 times and then say there weren't any options for the other ones? Oh, cool, James. Yeah. Okay, so first time through, solving the puzzle. We're saying there's nothing. That's correct. There should be nothing. We get through to here. We need to set the initial value. We should have one option. Let me put options there so that we get the number at this point. So there's one option. That should just be the 4. We're going to insert in the 4 because that was our only choice. We're then going to get down here. We're going to come in. This should be a new puzzle that we're trying to solve, which is this one, which should be solvable. And so this next one, we're going to come in here. We're going to check 0, 0. And 0, 0 has a value. So we should be continuing on to the next time through the loop. And we do. We're at y of 0 and an x of 1. And they're saying there's no valid options? What do you mean? Why did we get back no valid options? We should have had a valid option there. Okay. Okay. Derp, I found the mistake, guys. I found the mistake, everyone. Fixed. Whoops, I meant to do... Well, there's why our code was failing. I told you there was going to be something simple like that was borking it. Let's hope that that's all it was, and that then it works. Hey, there we go. Oh man, I knew it was something stupid, and you're right. I think Renee asked at one point if I was correct that, or someone asked if it was definitely YX. I think it was Renee that asked that, and it is YX, and in one place I wrote it the other way because big old derp. But there's why we kept failing forever, and we're like, debug this, like there's something wrong. Why doesn't this code work at all? So there we go. The little pop-ups with the values while debugging. Andre, that might be ReSharper that's doing that. That could be CodeLens that's doing it. So it could be just part of Visual Studio. I am running a high enough version of Visual Studio. This is not Community Edition. I don't remember which thing does it. And hey, Jen's Duck, welcome. And Lucky, welcome, Lucky. Greetings. Just popping in to say, oh yeah, have a great end of your 2018, Lucky. Thanks for being here. I will see you in 2019. Because it'll be 2019 for you really soon. Yeah, exactly, Renee. That's what I'm saying. Like, you were right. Like, bringing up that, yeah, that was the complex thing. And it was somewhere else that the problem was. But that question was perfect. Because it is a little weird. Like, which one is it? Let's see if these can just work now. And if so, then I want to put in, like... I want to put in some short circuits so we can make it go faster. Because the simple test is relatively quick because we're only filling in a couple of values, but these last ones, since we're brute forcing it really, really poorly, like we're being, like it is dumb right now. It's like trying so many options, it's insane. But it might be able to work still. And yeah, Andre, it's one of these things. There's a lot of good tools that definitely help out in just seeing this kind of stuff. Very, very useful. We'll see you in 2019. You won't see us. Actually, I will see Lucky. Lucky streams with a webcam, so I can see Lucky on his stream too. So. And Renee, I think this feature is just built into Visual Studio Professional Edition. But either way, this is running too long. I'm gonna kill this. I don't know why that's taken so long. Maybe I wrote the code so that it would just run on forever and ever. I don't think we infinite looped, but I do think that that we got caught in a very large execution, and we need to short circuit a little bit better. Okay, so if options.any, so if there are no options, continue. Wait, return. If there aren't any options, we need to, like, break, right? There's no sense continuing this. I don't need to continue this row if I can't fill in a value, and we didn't continue. I need to break. Which I'll put there. And then here we need to say if get row values of y dot any are zeros, means we couldn't fill them in, and these are not going to be called x because that'll get confusing. If any cell is 0, then break. And break is going to be the same thing as that return because it'll break us out and get us there, I think. So I think he was talking. I think Andre was talking about the displaying of them without the pop-ups. Resharper does not use the C# compiler. It parses as yes. Yes, that is correct. So Voight is actually pointing out the reason why people notice performance issues in Resharper, and that is the fact that Resharper had already built all these tools for doing their analysis, and Roslyn kind of does some of that same thing, and instead of abandoning what they'd built and just using Roslyn, they decided to keep using their stuff, as far as I'm aware. I obviously don't work at Resharper, but that's what I recall being the scenario. Because they had a very robust analysis system. So, who knows? Okay, let's see. Let's go run that test again.
Oh, what a day! What a lovely day!
And, Boogie, welcome. Thanks for that follow, much appreciated. Let's see, does this speed up at all? Oh, man, look at that. That was like lightning. Man, that simple break just solves everything. It's basically stop trying to work once you've figured out that it doesn't work at all. Does that last one pass? Ooh, that last one seems tougher. Because it's still going. Wow. Whatever this one is, this one's a struggle. CodeRush had the same issue and rewrote from the ground up for Roslyn. Nice, Simon. I didn't know that they they did that. That explains why they have the new version that's called like the Roslyn version. Is CodeRush building a tool for VS Code? If they are, that's cool. I don't know of one. Oh, come on. Now I've got two Andre. I was shortening Andre to Andre, and now I've got Andre 88 UK. Also, I guess I'll go with 88. Congratulations. You now have the number 88. Which I'm guessing is maybe yeah, you've been here before. You'll be on Andre 1. Yes. I can't deal with multiple Andres. What is this? No. Welcome everyone. Yeah, no, it's okay if you have a repeat name. It's just I might be confusing. I might get confusing if I start calling people by that. Why is that still going? We'll debug this one. What's going on? Do I have any breakpoints? That breakpoint should hit all the time, so I don't want that one there. Is set complete? Ooh, cool. Row 0, it says, is done. So if I actually look at the data of that row, it should be done. Yeah, that's done. Cool. Okay, I can see it filling in values when I watch down here. That's weird, because it has to call every time and re-say that it's done with number 1. Now it's done with number 2. Wait, hang on. Oh, it must have put an invalid value in that one. Right, because every time it puts in an invalid value, we have to return and start over again with a new puzzle. Yeah, right now we're just readjusting some basic values. Why am I resetting row 2? Row 2 is change. I'm seeing row 2's values change. We're shifting around row 2. And by row 2 I mean y equals 1. Even though y equals 1 was done. So y equals 1 is done here. Why are we still checking anything in the previous one? I worked in a small company one time that had 10 employees and 3 of them were named Michelle. It's always crazy. Let's see what's going on in chat. Pretty soon there'll be Andre 9000. You were like, what Andre said. Wait, I didn't type anything. Chatter 0. Stool Penner, best suggestion. Yes. We have a whole bunch of chatters. They're numbered 0 through N. It's nice to be in a small team with all members having the same name. Actually, in my high school job, there were 5 employees, all with the same first name, which was crazy. Yeah, Fuel Snable. They were Michelle's. One of them spelled it with 1 L, the others with 2. So there was Michelle 1, Michelle 2, and 1 L. 5 Renees in an 80-person company can give fun. Exactly, yes. Like, if you're not in that large of a company, you can run into some problems. Yeah, CodeRush is a very nice tool. They do a great job making it look super fancy. seriously, if they added the handful of stuff that I asked Mark for like a decade ago, I told him, here's the list of stuff, you build this in CodeRush, I will switch to CodeRush. He hasn't built me those yet. I've been waiting. Waiting and waiting. Mark's probably in chat now and he's going to be like, what were those things? Okay, so when we go through this, when can we short circuit?
What a lovely day!
I think the slightly faster check than is it complete, because we don't really care if it's, like, we're not checking the validity yet, is going to be get row values for y dot all are greater than 0. If all the current values are greater than 0, then continue. We don't need to do a full check of the row. We can go to the next row. For this one, if the column is greater than, if that specific value is greater than 0, we can continue. So those are our basic continues. When this succeeds, when we find one that succeeds, we return and we don't continue on. So that should exit us out, and we should not continue working in there. We should be like, oh, that would just be an attempt success. Ooh, if all the attempts, so if we don't go through, that means that all the attempts failed. We should go down the full path, filling in all the values. If there are no options, we break out of there. If there are no options there, we break out of there. This still finishes like lightning? Yeah. But the lower one doesn't. What do the puzzles look like? Was puzzle 1 just way easier? Quantity of zeros looks similar between puzzle 1 and puzzle 2. But when I run this, it doesn't finish. Hey, Janisku, you made it to 2019. Congratulations. Happy New Year. So yeah, it's I know we have a lot of German viewers here on the channel. So anyone that's UTC plus 2? If you're currently in that, Happy New Year. So, yeah, I have actually tried Rider. We've used it on the stream once. And yeah, I'm betting as a Unity developer is probably quite nice, because Unity is already kind of a weird world for C# anyway. And yes, Johan, anybody in the Netherlands, Belgium, we've got most of Europe is at UTC plus 1 right now. significant amount of the population is, yeah. So yes, happy 2019, everyone. Why is that running so slowly? So the fact that test 1 completes tells me this code probably works, but I've got a spot where I can short circuit. So, and we need to do that. That's basically what needs to happen. Let's see. Let's call this basic brute force.
Oh, what a day!
We will commit that change. Yes. Fireworks and the like. MSK, hey, welcome. Greetings, everyone. Hopefully you're all having a pretty good end of the year here. So what else can we short circuit? Where can we save some time? So we create new puzzles here with those values. Give valid options is actually happening after a greater than 0 check, so that technically can never happen. And the unit test should confirm I don't need my short circuit. Let's go ahead and run all the tests. And all except that last one should just pass, because I think they're going to run first. Oh, one failed. Ah, bummer. It was a filled cell, it didn't check itself. Probably returned back with the value that it was. It's a quick check, so we won't worry too much about it, but it can't technically happen, so that's the silly part. Today's your last night. Oh, yeah, well, Andre, yeah, that's not, it's a good idea to make sure you're sober if you actually have to be, able to respond to things 24/7. Can you count the number of iterations? Yeah. Yeah, we could count the number of iterations that we've done pretty easily, in a couple of ways. We're probably doing a mass ton. So let's do this to start off with. Created count equals 0, and let's do this. Created count plus plus. And before each test, debug.print. We're gonna say before simple, we're gonna say puzzle created count. That's before test 1. And I can even I should be able to reset that value also. Whoops. Before test 2. And this won't give me numbers here, but let's see basically what we get when we run these for the earlier ones. Oh, I need to be debugging to actually see those values. That's a good point. Am I printing out the puzzles? I'm printing out the puzzles. Stop. Remove the breakpoints for now. I don't need them. And comment this out. Hang on one sec. Welcome, Toby. Thanks for following, much appreciated. And if I missed anybody else, welcome as well. Thank you for following, always appreciated. Oh, I still have the previous test run going, maybe? Stop. That's why it couldn't debug that. Debug. I forgot to stop the previous test run, because it was still going. So before simple, after simple, I didn't... So simple created 10 of them. Before test 1, we had 10. So we created 60 new instances to make that one. And test, yeah, so test 1. And then test 2 does not finish. Oh, wait, I got a green check mark. Wait, it passed? Well, that's crazy. I don't think I changed anything about it. Except removing the debug prints. The debug print was slowing it down so much that it couldn't finish. I don't know if I've mentioned, but debug, like console commands, like console writing, actually slows you down a lot. I don't know if I've ever mentioned that. Yeah, Andre, I wasn't thinking about it at first, but I think it's gonna pass now. I think it wasn't able to complete because debugging like writing to a console is actually much slower than people really. Yeah, it finishes quickly now. I had to think about it, but yeah, that's actually why. So if you've ever run into that before, a lot of times it is like if you don't write to the console at all, it's faster, and that includes debugging messages. So those debugging messages we were sending out constantly, that's what was slowing it down. So now that those are gone, do we get these messages? I'm gonna breakpoint right here. So it should start at 0. Let's see what it says. Where did my debug print message go? Oh my god. Oh my. I created 750,000 puzzle objects. Oh man, that's awesome. Big Drolly, I actually don't know on that one. It might depend on the circumstances, but this is hilarious. Brave Cobra, 750,000 was bigger than I expected. I knew it was gonna be a lot, but that's a good number. I know, right? Yeah. Wait, queued. Queued? Queued? Oh man, that's good. That's good. Is that literally our only change now? Yes. Yes, it is. So in that case, I'm going to discard all changes. So this really is the version that works. So if we comment that out, comment out debugging code. Johan, yeah, happy 2019. Yes, exactly, Will. The dev speller. How did you learn to program? Toby, I actually learned to program back in the 90s. I like to use the term community-taught developer because I don't like the term self-taught because I like to give credit where it's due, and a lot of credit for many people learning how to code. Really, like, while yes, we are self-motivated on it, we get a lot of assistance from the community. So that comes from like reading someone else's blog about something, you know, reading articles about it online, you know, go checking forum posts, things like that, looking at other people's code to see how they did it, you know, digging through GitHub and whatnot. That all goes into community taught. Yeah, Edmund, I love, exactly, yes. I have been trying to spread community taught for a while. I love the concept because, yeah, a lot of us, you know, like, yeah, it's like, yeah, you're a self-taught developer. I mean, I after being community taught how to program, I went on and I got a degree in computer science, so I actually do have, like, a computer science background as well. And I've been working in the industry for a while. I've, you know, worked with a lot of very smart people who I have learned a great deal from over the years. So community taught developer, I think, is a great term. And yes.
What a lovely day!
And thanks for the follow, Ed. And Johan, also, I think I mentioned thanks for the biddies. If I didn't, thank you as well. But yes, Ed, that is totally true. The number of random people on the internet that we've never met before that we owe a lot to is huge, and that's why I love community taught, because, like, I would not be anywhere near where I am as a developer today without a massive community of developers helping each other all the time. Fuel Snable, there might be some, but yeah, exactly. I'm worried because I really want to be a software developer when I go to college, but I'm not good at math. Oh, Toby, math is actually not all that required for programming for most programming jobs. It depends on which ones you get, but the majority of them you just need to be reasonably okay at basic mathematics. So numbers, counting, simple arithmetic. You don't need to be good at calculus, for example, or, you know, really any of the difficult math in order to do well in programming. Exactly. Yes, Ed. You can absolutely learn Java and really any programming language on the internet really easily now. Yes, exactly. Yes, you don't. That's why I don't like the self-taught term, because it usually isn't true. Even if you looked at the manual pages and the documentation only, that's still community taught. Unless all you did was receive a compiler and just bang your head against the wall until it worked without even reading a man page, I might give you self-taught then, but a lot of us are community taught. Yeah, no problem, Toby. Keep at it, and you know, as we mentioned, you can learn a lot from the community as well, so do that, and go to college to get the piece of paper to get the job afterwards if you want, but if that's the route that you're planning on taking, but yeah. Yes, and Voight is correct. You'll need to be able to pass those courses in order to get the degree. That doesn't necessarily mean that you have to be great at math, but you do usually need to pass some math classes. Yes, very, very true. One of the biggest things we're getting a programming job is being able to read code well. Common sense is the only requirement for a program. I would say being able to logic your way through things, being able to apply logic to a problem and find solutions. So, okay, cool. So I think this kata works, but I think I need to give direction on it. So what we were doing today, we were trying out a kata that I was trying to build. So I'm trying to figure out how the Sudoku solver kata can work, and sort of like as the person trying it, I think what I ran into is I didn't have enough direction on where to go and where to start. So I think we need to give a little bit more guidance, not necessarily on the solution, but easier ways to go down, maybe a bigger test harness to begin with, maybe something like that. I'm not sure, but I think it worked reasonably well. Toby, Python's a decent starting. There are a lot of great starting languages. Python's a good starting language. I actually think C# is a good starting language, although people will argue with me on that one. Some will shout for C++. I think it depends on what you want to do, what community you find that works well for you. You want to find teachers, mentors, which articles make sense to you. But in addition, Toby, I would say if you know what language the school is going to teach you, you can learn that language, and that's a good approach. Seashell, welcome, thanks for following. And the other option is look at what field you want to go into. So for example, if you know that you want to go work at, like, you know, oh, I want to go work at NASA, maybe that's what you want to do. Probably not that one, but maybe that's what you want to do. You can go find out what programming languages do they use, and then, you know, make sure that you learn those. So for example, someone in chat mentioned that they are a Unity developer. So Unity, for example, uses C#. If you wanted to learn Unity and do game development in that, C# is the way to do it. You could look at, so if you want to go work in the corporate world, almost any corporate language will work, almost any like general purpose language. So your Javas, your C#, your Pythons, a lot of those are gonna do well for you. You'll probably want to look into web development if you want to go into the business world, because it's very, very common still. And at some point, you'll probably want to look at mobile development as well, because a lot of businesses are doing that. So there's a lot of areas, so look into those. I didn't think Unity supported JavaScript anymore. Maybe I'm wrong. Edmund, so we were just trying out a kata today. Was all we were doing. So I want to develop a kata that other people can use, and so that's what we were working on here. So this is a Sudoku solver, and I do want to mention to everyone that is new here that here on DevChatter I actually stream 4 times a week. And it's Mondays, Tuesdays, Thursdays, and Saturdays. Obviously, I don't usually stream on holidays and things like that. Today's New Year's Eve, which, you know, special thing. So if it is close to your New Year, Happy New Year. If you are, you know, maybe you're already in it. So welcome to 2019 if you are. I'm not there yet, but I will be. So yeah, we stream 4 times a week. And if you don't know our schedule, you can probably find it down below, and you can also check with our bot, which hopefully is running right now. So maybe you live in, someone said they lived in, I don't know. We'll just do England. So my schedule for anyone that lives in England looks like I start on Mondays at 7 p.m., Tuesdays at 7 p.m., Thursdays at 5, and Saturdays at 6. So I'm in the evening in England. So we've got that stuff. Glad you like it, Seashell. There's some awesome stuff. They're all our derpy dinosaur stuff, which we're a big fan of. And let's see. And yeah, so Riggin, yeah, language doesn't matter as much. That's why I say to find the language that you like. There are a lot of languages that are good for starting. So find what you want to do. Wait, what? Time in the Netherlands. What time? Oh, it should be schedule in the Netherlands. Yeah. You'll make sure you pop in regularly. Glad you like it, Toby. So, for anyone that is wondering, The best way to know when we're streaming, what's going on, and to chat with other developers is to join our Discord. The other way to find out when streams and other things are going on is to follow me on Twitter. I'm at Brendonius, and I linked over there in the chat to both the Discord and my Twitter. And the other things, all the code that we do here on the stream is actually out on GitHub, so you can go to github.com/devchatter, and I will click that link and show all of you where that goes, which actually I should have opened it here. It will take you out to this URL right here, where you can find all the code that we do here on the stream. So if you want to check out any of that, this is the place to do it. Today we were working on the Sudoku kata that we're building. I need to write up the instructions for it, which is really how someone would do the kata. But I want to make it so that we can do this in multiple languages, and we basically give someone a test harness and say, go. For part of this, we're going to need good test data and things like that, and so that's kind of why I wanted to give it a try on stream. So a few takeaways that I've got. We need some simple puzzles to start, so some of the ones where it's like you just need to fill in a row, and like that's a great starting point, so we just added that one as a test today. I want to try adding some of those, so like there's a reasonable progression, like, you know, you can fill in a whole row of data or fill in a whole column, but, you know, not have to solve a whole puzzle. And I think that'll make it a little bit easier. And yeah, thanks everybody for chiming in with answers in the chat. Feel free to answer questions if people ask them. If you want to see archives of our videos, you can... Oh, that's a cool idea, Reagan. I did not know about that there's a place that has ideas like that. You can actually find archives of all of our videos here on the stream in the video section on Twitch. And alternative to that, you can actually find our full archive over at YouTube, because for some reason Twitch doesn't keep our full archive. They only keep the videos so long, so we do have to move them. And other than that one, I am actually gonna bail on you guys at about this time. But as I said, be sure to follow me on Twitter and here on Twitch so that you can catch our future streams. That is the best thing to just to do if you want to get this great content basically every week. As you might notice, we're on episode 156 of DevChatter. So we started this stream in like February, something like that, and have been going for quite a long time. So Happy New Year, everyone. I'm looking forward to 2019. We have some great plans for what we're going to do on the stream then. We are going to be doing... I had mentioned to people we're going to be doing some new stuff. We're going to look at F# at some point in 2019. We're definitely going to look at Unity at some point in 2019. I haven't messed with either of those in quite a long time. So we're definitely going to do some fun things there. I've got guests that I am lining up to be on the stream. A bunch of people I had talked to, I was like, I'm going to catch back up with you in January. So we're going to be doing those sorts of things. And yeah, either way, feel free to check out stuff below. Have a happy new year. And I think I'm going to see you guys tomorrow, but there's not a 100% guarantee because with tomorrow being a holiday, we'll see. But I am planning on it. So tomorrow at our regularly scheduled time. So thank you for hanging out, everyone. Enjoy your New Year's. If you're not there yet, stay safe, and I will see you in 2019. Happy coding, everyone. Bye.